This is section 4.2, tangents, normals, and derivatives. By the end of this lesson, you should be able to find equations of lines that are tangent and normal to curves using derivatives. So we've talked enough about what a tangent is and what a tangent is not, but a tangent obviously has to pass through a point and have the slope of the curve at that point, right? For example, this passes through a point, but is not considered a tangent because it does not have the slope of the curve at that point. The normal to a curve at a point P is a line that is perpendicular to the tangent at P. So normal is just going to be perpendicular to the tangent. We can see some information here on the screen that is review of material previously covered. So for example, like slope of parallel lines, the slopes of parallel lines are equal. The slope of perpendicular lines are negative reciprocals of each other. So this is key to understanding the normal. So for example, if a normal is perpendicular to the tangent, the slope of the normal is going to be the negative reciprocal of the slope of the tangent, right? Because it's perpendicular. Slope of a horizontal line is 0. Slope of a vertical line is undefined. Again, this is all material we've talked about before, and you've actually even seen this stuff since as early as grade 9. Equation of the lines, this is slope-intercept form, y equals mx plus b. Equation of slope. Equation of the line in point-slope form. This is pretty helpful. If you just have the slope and one point, you can use this equation and rearrange for slope-intercept form. And then you also have equation of the line in standard form. And you may not have seen this for a while, but standard form is just capital AX plus capital BY plus capital C is equal to 0. And typically A right here is going to be a positive. It is positive. Okay, we keep A as a positive number. All right. Example 1. Find the equations of a line which are tangent and then normal to this curve. So we're going to first find the equations of the line which are tangent to this curve at x is equal to 4. And then we're going to find the equations of the line that are normal to this curve at x is equal to 4. Okay, so recall that if you want the equation of a line, okay, it's important to have the slope and a point. Okay, now alternatively, if you have 2 points, you can find the slope and then find the equation of the line. But frequently in these questions, we're going to get the slope, have a point, and then do point-slope form. This is stuff that we've all done before. Okay, this should be kind of a review. All right, the first thing that we're going to do is we're going to find this point because we have x is equal to 4 and we have the equation of the curve. So by subbing in x is equal to 4 into the equation of the curve, we can find the y value. So the first thing I'm going to do is I'm going to sub x is equal to 4 to find my y value. So here we go. I got y is equal to 2, 4 squared minus 8 times 4 plus 4 to the power of 3 over 2. And when I input that into my calculator and evaluate it, I get 32 minus 32 plus 8. So y is equal to 8. So I now have my point. Therefore, the point is going to be the x value of 4 and the y value by subbing the x value into here is 8. Okay, so I've got my point. Now, to find my slope, I'm going to take the first derivative of this curve and sub in x is equal to 4. That's going to give me the slope of the tangent at x is equal to 4. Okay, so I'm going to find the derivative of this curve with respect to x. So dy dx, the derivative of y with respect to x. Okay, this is no different than writing y prime, right, is equal to, so let's use our power rule. We bring the 2 down, multiply it by this 2. 4x that power right there. We're going to subtract 1, so we get 4x to the power of 1. Okay, this should just be minus 8. And for this final term here, we're going to bring the 3 over 2 down. Okay, and then we're going to take this 3 over 2 and we're going to subtract by 1. So a way to think about that is x to the 3 over 2 minus 1 is x to the 3 over 2 minus 2 over 2. So we get x to the 1/2 right there. Okay, so here is the derivative. And now what I'm going to do is I'm going to evaluate this derivative at x is equal to 4. So I'm going to find the slope of the tangent line at x is equal to 4. So I just sub in 4. Okay, and I find that the derivative at 4 is equal to 11. Okay, so what I can say now is I can say that therefore the slope, or m, of the tangent line is equal to 11. Now that you have the point and you have the slope, you can find the equation of the line. Now, as usual, you can do this with y equals mx plus b. But we're going to be doing this quite a lot in this chapter here, so I'm just going to go ahead and I'm going to use point slope form. So y minus y1 is equal to m x minus x1. So I sub in my y value, which was 8, my slope, which is 11, and my x value, which is 4. I rearrange, and I get y is equal to 11x minus 36. Okay, so that is my final answer. That is the slope of the tangent line. Okay, that's my final answer there. Or rather, that's the equation of the tangent line. So I'll write that right there. Equation of tangent line. What I need to do now is I need to find the normal to this curve. Well, like we said, the normal is perpendicular to this tangent line. So if it's perpendicular to this tangent line, then the slope of the normal, so therefore slope of the normal, is equal to the negative reciprocal of the slope of the tangent. So the slope of the tangent is 11, the slope of the normal is negative 1 over 11. It still passes through the point 4, 8. Right? We're going to find the normal to the curve at that point. So it's still going to pass through this point, but it's going to have the negative reciprocal slope to the, of the tangent. Right? So again, I'm just going to go ahead and I'm going to use my my point slope form. Y minus 8 is equal to negative 1 over 11, and then I've got x minus 4. Okay. What I'm going to do is I'm going to get rid of this 11. I'm going to clear this fraction. In order to clear this fraction, what I'm going to do is I'm going to multiply both sides by 11. By multiplying both sides by 11, that allows me to cancel these 11s here, because remember, the order of multiplication doesn't matter, right? I could have just done this right here. I could have said, okay, you know what? This, I'm going to multiply here. This multiply here, move this over, order of multiplication doesn't matter, so therefore, here we go, cancels, cancels. Okay, and so I end up with 11 times y minus 8 is equal to negative x minus 4, and then I can rearrange and solve for y. And when I rearrange and solve for y here, if you want, I can expand this in. 11y minus 88 is equal to negative x plus 4. Okay, and then if I want to put it into standard form, remember my x has to be positive, so bring my x over. X plus 11y minus 88 minus 4 equals to 0. X plus 11y and then minus 92 is equal to 0. And that's your equation of the line in standard form. Alternatively, we can also just put that into y equals mx plus b form, which is negative 1 over 11x plus 92 over 11. Okay, so to recap, I found the equation of the tangent. As we normally do, we sub the x value into the equation, find the point, take the first derivative, sub in the value of x is equal to 4, find the slope of the tangent, slope point form or point slope form, and or y equals mx plus b, whatever your preference is, find the equation of the tangent line. If it's the normal, it's got the negative reciprocal, same idea here, and then we find the equation right there. This is the equation of my normal. Okay, so here we go, equation of normal. Okay, we're going to keep going here, and we're going to look at example 2. The complexity is going to increase a little bit as we go along here. So it says a particular tangent line to the curve y is equal to 1 over 4x cubed has a slope of 12. Find all possible equations of this tangent line. Okay, so as you can see here, they've given me the slope of the tangent, right? So therefore, the slope of the tangent is equal to 12. And you will recall that the slope of the tangent, right, is just the first derivative, right? And so that's either y prime or dy dx, which in this case is 12. So if I take this first derivative here, let me take this first derivative, y prime is equal to 1 over 4, right? I bring the 3 down, and then I subtract the exponent by 1. So my y prime, or dy dx, is equal to 3 over 4 x squared. But as you can see, I already have the value of the slope of the tangent. The slope of the tangent is 12. So I can sub y prime equal to 12 and find the x value at which that takes place. So 12 is equal to 3 over 4 times x squared. Now, I want to get rid of this 3 over 4. So what I'm going to do is, and again, remember I said order of multiplication doesn't matter, right? So I'm just going to move that over there. And I'm going to multiply both sides by 4 over 3. And you'll see that I'm multiplying both sides by 4 over 3 because that allows me to cancel this fraction in one step. And then I will end up having 48 over 3 is equal to x squared. Well, 48 over 3 is just 16. 16 is equal to x squared. And now I'm going to take the square root of both sides, but remember, I need to take the plus or minus square root of both sides to find both values of x. So therefore, x could be positive 4, but it could also be negative 4, because negative 4 squared is also equal to 16. So what I just have found is that, okay, therefore, at x is equal to 4, the slope y prime is equal to 12, and at x is equal to negative 4, y prime is equal to 12. So what I will actually have is I'll actually have 2 lines where the slope of the tangent is 12. So here we go. I'm going to do my first line, okay? So this is going to be line 1, and that's when x is equal to 4. So the first tangent, right, that has a slope of 12 when x is equal to 4. So when x is equal to 4, I need to find my y value. So I'm going to sub 4 into the equation of the curve right here. So y is equal to 1 over 4 and then 4 cubed. And so y is equal to 16. So therefore, my point on this line is going to be 416. And to find the equation of that line, I'm going to use my point slope form. So y minus y1, 16. The slope, we already said, is 12. 12. X minus x1, which is 4. Okay, rearrange, isolate for y. Y is equal to 12x minus 32. Okay, so that's the equation of one of the lines when x is equal to 4. But remember, x could also equal negative 4. Because when I subbed y prime equal to 12 for this slope, I got two possible x values where the slope is 12. So here we go, I've got another line. Line 2, and that's when x is equal to negative 4. Okay, so I sub that in. Y is equal to 1 over 4, negative 4 cubed. This gives me negative 16, so therefore my point is 4, negative 16. I do the same thing. Y minus negative 16, right? If you want, you don't need that bracket, but x minus 4, okay, and then we get y is equal to 12x plus 32. Okay, so as we can see here, there were two tangent lines to this curve that had a slope of 12. The first tangent line has this equation, and the second tangent line has this equation. That's why it says find all possible equations of the lines, because there's two tangent lines in this example. All right, example 3. We keep going, and we see find the equations of all tangents to this curve which are perpendicular to this line. So looks like I'm going to have to find, it says find the equations of all tangents that are perpendicular to this line. All right. So the first thing I'm going to do is, these are in kind of, strange form, right? Like, for example, I can't really find the slope just by looking at this. So what I might do here is I might take this and I might rearrange this into y equals mx plus b. Okay. So I'm going to rearrange to y equals mx plus b so I can get the slope of this, because the tangent has to be perpendicular to this, so I need the slope of this line. So x plus 5y equals 10, 5y equals negative x plus 10, y is equal to, okay, so that's negative 1x, so I'm going to divide everything, so negative 1 over 5x plus 2. Okay, so the slope of this line is equal to negative 1 over 5. If I'm looking for the tangents that are perpendicular to that line, I'm going to have to use the negative reciprocal. I'm also going to rearrange this right here so I can find the first derivative very easily. So I'm going to rearrange this so that my y is by itself. X to the power of 5 is equal to 16y, right? I just brought the 16 over. So 1 over 16 x to the power of 5 is equal to y. And now I can take the derivative relatively easily because I need y by itself if I want to take dy dx, or the first derivative. Okay, so what I'm going to do is I'm going to take the first derivative here, so I'm going to find dy dx. And I get 1 over 16 times 5 x to the power of 4, so dy dx is equal to 5 over 16 x to the power of 4, right? And so this is remember, this is the first derivative of this curve right there, right? So that's the derivative of the curve. And you'll recall that the derivative of the curve is the slope of the tangent. Now, do I have the slope of the tangent? No, but I know that the tangent has to be perpendicular to this line right here, and this line had a slope of negative 1 over 5. So therefore, dy over dx, so the derivative, must be equal to 5 if perpendicular to x plus 5y equals 10. So the tangent, if it's perpendicular to this line, and this line has a slope of negative 1 over 5, the tangent has to have a slope of 5. So if dy dx has a slope of 5, then therefore 5, right, first derivative is equal to 5 over 16 x to the power of 4. I want to get x by itself, and you may have guessed it from before. What I'm going to do, I'm just going to multiply it by the reciprocal of the coefficient there. And the 5 and the 5 cancel, and the 16 and the 16 cancel, and the 5 and the 5 cancel here. So 16 is equal to x to the power of 4. Well, if we think, what number raised to the power of 4 gives us 16? Well, that could be positive 2, but it could also be negative 2. So again, we see there are two x values where the tangents are perpendicular to this line. Okay, so we can say, therefore, there are two x values where the tangent is perpendicular to x plus 5y is equal to 10. So if there's two x values where it's perpendicular to that, that means that I've got actually two possible lines. Okay, so here we go. Same thing as before, line 1, and that's when x is equal to 2. Well, same as before, if I just have my x value, I need my y value, so I'm going to need to sub this x value back into the equation of the original function. So y is equal to, and if you see right here, y is equal to 1 over 16 x to the power of 5. So 1 over 16 and then 2 to the power of 5 because I'm subbing x in right there. And y is equal to 2. Okay, so therefore my point is 2, 2. I know that my slope, right, we already said that the slope of this is equal to 5, right? The slope of the tangent equals 5 because it was perpendicular to this line, and this line had a slope of negative 1 over 5. So the tangent line slope is 5. Okay, I'm going to use my point slope form, rearrange, and isolate for y. And this is my first equation right here. Okay. So this is the equation of the first tangent that is perpendicular to the line given in the question. But remember, there were two x values, so I need to find the other tangent line. And the other tangent line happens when x is equal to negative 2. And so I sub negative 2 into the equation. And I get back negative 2. So my point is negative 2, negative 2. I use my point slope form, y minus negative 2, 5x minus negative 2. You can just switch that to a positive if you want, and you get y is equal to 5x plus 8. Okay, again, that is the equation of the second line that is tangent to this curve and perpendicular to this line. So if we reread the question, find the equations of all tangents of this curve which are perpendicular to this line. We found the slope of that line so that we could set the first derivative to the negative reciprocal because it's perpendicular. We solved for the x value when that occurs. We found that there were two x values. And then we found the equations of the tangents at each of those x values. Y is equal to 5x minus 8. Y is equal to 5x plus 8. So So as you can see, the complexity is definitely ramping up here. We finished with example 4, and example 4 may be one of the more challenging examples. Two lines pass through the point 3, 9 and are tangent to this parabola. Now another way of writing this parabola is just this: y is equal to negative x squared plus 2. And you might think of that and, okay, think about your transformations. Well, what does this mean right here? This negative, well, that's a reflection in x. And this means that it's vertically shifted to up. Okay, so if I was to just sketch a rough graph of this parabola, okay, I'm going to put an XY axis here. Okay, just kind of sketch a squiggly one apparently. Okay, here we go. And I have my vertex, which is going to be at this point right here, right, 0, 2, it's been shifted up, and my parabola is opening down. Right, so it's going here, and it's going here. And it says, two lines pass through the point 3, 9 and are tangent to this curve. So if I put 3, 9 here, 3, 9 is like, say, somewhere over here, we'll say, right? That's my 3, 9. It says find the points of contact with of these lines with the curve. So I've got a line that passes through 3, 9 and is tangent to this. So it's passing through and is tangent to this. So it's basically doing something like this, right? And is tangent to the curve at that point right there. We'll just assume that that connects. And then I've got another line that is tangent and basically comes down here, something like that. So it's tangent over here. And so the question is asking me find the points of contact of these lines with this curve. Okay, let me just clean this up a little bit. This is 3, 9. So this diagram should help you visualize what this example is asking. It's saying that there's going to be two lines here that are tangent to this curve, and they have to pass through this point. This point is not on this curve. It's just some random point up here, and there are tangent lines that pass through it. Okay, so the challenging part of this question is recognizing that we have these 2 points here, and we have the tangent lines as well, and think about how we can use these points right here and slope to find the point of contact. All right, so let's think about this point right here. I'm just going to call this point here X and Y because I don't know what that point is. All right, but if it's a point on that curve, that means X is the independent variable, and y, I already know what y is on that curve. Instead of writing y, I can just write 2 minus x squared, because that's what y is on this parabola, right? If I want to find a point on y, or a point on the parabola, I sub in an x value, and it will generate that y value. So my y for this parabola is just 2 minus x squared. Okay, so I'm going to find slope of this one right here. Okay, slope of line 1. So if I want to find the slope of line 1, I can use the formula that we saw right at the beginning, right here. y2 minus y1, x2 minus x1. That's the formula for slope that you've seen for a long time, right? This is a line. It's a tangent line, but if it has a slope, it can be found as y2 minus y1, x2 minus x1. So y2, we'll say, is 9. And y1 is going to be this value right here, right? But this value over here, remember this y value, I can restate it as 2 minus x squared. So 2 minus x squared. And then x2 is 3, And x1, well, that's just this x value right here. So the slope of line 1 is given by this formula right here. But I also have to remember that line 1 is a tangent. And if it is a tangent, the slope of the tangent is the derivative. So what I can do is I can find the derivative of this one right here. So the derivative of this function right here is going to be equal to negative 2x. That's the derivative of that right there. And this is also the slope of the tangent, right? That is the slope of the tangent, and line 1 is a tangent. So I have the slope of line 1 in this equation. I also have the slope of line 1 given by this equation. So I can just make them equal to each other because they're both slopes. So therefore, negative 2x is equal to 9 minus, I'll distribute the negative, minus 2 plus x squared all over 3 minus x. All right? So what I'm going to do here is I'm going to rearrange and solve for x here. So I will take both sides and I'm going to multiply both sides by, I'll just take this right here, I'll recopy it. Okay. I'm going to take both sides and I'm going to multiply by 3 minus x. That will cancel, this will cancel, okay. And I end up with, right here, negative 2x times 3 is negative 6x. And then negative 2x times negative x is plus 2x squared. And then 9 minus 2 is 7, and then I have plus x squared. Right? I no longer have a denominator, the denominator canceled. Okay, I'm going to bring everything over to one side. This is a quadratic equation. So I'm going to take everything over to one side, and I'm going to say 2x squared minus x squared minus 6x minus 7 is equal to 0. X squared minus 6x minus 7 is equal to 0. So that means that this can factor into x minus 7 and x plus 1 is equal to 0. So by the zero product property, x could be equal to 7 or x could be equal to negative 1. Well, let's think right here. Let's go back to my diagram. What is this point right here? Is that x is equal to 7 or is that x is equal to negative 1? This point right here is, this one is the point on line 1. So that's my line 1 point. X is equal to 7 is my point on line 2. I've color coded it for you right here. So this point right there, that's equal to 7. So how will I find my, that's negative 1, right? Negative 1 and then 7. How will I find my y value? Well, in order to find my y value, I'm just going to have to sub it, the x value, into this equation, right? So 2 minus negative 1 squared, 2 minus 1 squared, 2 minus 1 is just 1, right? And then let's put this in over here. Let's find out, well, what is the x value over here? Here, the x value, remember, it's just x, and then this is going to be 2 minus x squared, because that's my y value, right? So I sub in. 7 squared is 49, so 2 minus 49, that's negative 47. So clearly this diagram is not to scale, right? But I do have my 2 points, right? I have my x value. I just sub my x value in. Sub x is equal to 7. Y is equal to 2 minus 7 squared. Y is equal to 2 minus 49. Y is equal to negative 47. So 7 negative 47, 7 negative 47 is 1 point. And then same thing here. I sub x is equal to negative 1. Y is equal to 2. Minus negative 1 squared. Y is equal to 1. So negative 1, 1 is my other point. Okay, that's the lesson. So again, this is a combination of using, in this question, this was a combination of using your previous knowledge of slope, right? Slope of a line, y2 minus y1, x2 minus x1, right? Recognizing that the y value is defined as part of the curve, right? So y is equal to 2 minus x squared. Y is dependent on your x. And then in grade 12, we now know that the first derivative is the slope of the tangent. So we make the slope of the line equal to the slope of the tangent. And then we solve for our x values here. Okay, great. Thanks for watching.